practice with it tomorrow. Okay, so the word eliminate, like we said before, just means to cancel or to get rid of. So elimination is just a way to solve systems of equations. Can I put EQU for equations? Is that okay? It's a way to solve systems of equations either by adding or subtracting. Okay, so solve systems of equations by adding or subtracting different equations to eliminate a variable. So that is a really fancy way of saying what we're going to try to do is we're either going to add together equations or we're going to subtract equations so that we can either get rid of the x variable or the y variable. It doesn't necessarily matter which one we choose, but eliminate just means to get rid of is what we're going to do today. So just like we had different steps for solving for substitution, there are different steps to solve for elimination. So step one, you have to make sure the equations are lined up. That means they have to look the same. So if you put your x first in the first equation, it better be first in the second equation. They have to all match up. Step two, you are either going to add or subtract your equations. That's what elimination is, add or subtract your equations to eliminate the variable with a common coefficient. C-O-E. With a common coefficient. Who here knows what the word coefficient means? Yeah? Good. It's the same number, but where is like the coefficient located? Next to a variable. Right next to a variable. Good. So the number in front of the variable are going to be the ones that we're going to try to get rid of. So if they are the same number, that's going to be the one we try to get rid of. So that's step two. Step three, we're going to solve the equation for the remaining variable. Right, so it's just a little bit of algebra that we're going to do to either get that x or y by itself. And then step four, we're going to substitute or plug in, substitute our answer either into the original equation, and then we're going to solve for the other variable. So it's very similar to what we did for substitution before, where we have to take our answer and plug it in. We still have to do the same thing here for elimination. Okay, so let's take a look at our first example. So number one, step one, we've got two equations here listed for us. Step one is to make sure the equations are lined up. So vertically making sure that they're lined up. So if you look at these, you see the y's are in line, the x are in line, and the numbers are in line. So step one is already done for me. Step two is we're either going to add or subtract our equations that have a common coefficient. So if you're looking at number one, what is the coefficient or the number in front of the y variable right now? 1. It's just a 1. What's the number in front of my x variable? A 3. Now we're going to come down to the second one. What's your coefficient with the y in the second equation? A 1 again. And then what's your coefficient for the x? A 1. So the only two that match up are your y's. So we're going to work with our y's because we want to eliminate the ones that have the same coefficient. So these both have a 1, so that's what we're going to try to do. Now, this is a positive 1y, and this is a positive 1y. If I wanted to get rid of it, eliminate it, would I add those two together or would I subtract them? You would subtract them. Good. So we are going to subtract our two equations here. Okay. So now we've got 1y minus 1y. You just told me that eliminates, get rid of. That becomes 0. Now I do the same thing for the rest. If I have 3 x's and I take away 1 x, how many x's do I have? 2. 2 x's. And then be very careful with your signs here. This is +4 minus -2.
6.
It's +6. Good. So when you have minus a negative, it becomes a positive. So this becomes a +6. So that was step 2. Now you should notice you only have one variable, right? You only have x's now. You got rid of your y's. Now you're just looking at x's. So what I want to do from here is I want to solve for the x. So I want to get the x all by itself. What should I move over so I can get the x by itself? The 6 by doing what? Subtracting. Good. So now it just becomes some algebra. Those will cancel. 0 minus 6 gives you -6. And then we bring down our 2x. And then what's my last step to get the x by itself? Divide it by 2. What do you get for your x variable? Good. X is equal to -3. So that was actually step 3. We solved for the equation. Step 4 is the final step. We are now going to take our answer right here, our x variable, and we're going to plug it in to one of the equations. Now, it does not matter which equation you choose to plug it in. You'll get the same thing for both. Which one would you like to choose, the top equation or the bottom equation? Bottom. Good choice. So the bottom equation was y equals x minus 2. I'm just going to plug in -3 for my x variable. So I get y equals -3 minus 2. So your y variable is what? -5. And there you have it. There's your x coordinate and your y coordinate. And when we write it as a final solution, which one comes first? Good. -3, -5. And there you go. You just solved that same system of equations by elimination, getting rid of something. Okay. Thumbs up, thumbs down. How you feel about that one? Feel okay? In the middle? Okay, so we'll do a couple more. We'll see if you like this one more than substitution. You might find that this one's easier. Let's try number 2. Okay, step 1, make sure they are lined up correctly. Are they lined up correctly? Yep, okay. I would suggest adding in some coefficients. What goes in front of the x over here? A 1. I already have the 4 in front of my y. What about my second ones? What goes in front of the x?
1.
1, and what goes in front of the y? 1. Okay, so which one should I try to cancel, the x's or the y's? The x's this time, because those are the two that have the same coefficient. Okay, you got a +1x and a +1x. How do I get rid of it? I should subtract. Good. And now I just work from left to right. My x's cancel. If you want to put a 0 there, you can. Be careful with your y's. What's +4y minus -1y?
5y.
5y. Right, minus the negative makes it a positive. So this becomes 5y. So the hardest part about this is just the signs for sure. And then 13 minus 3 gives me 10. Yep. And I only have one step to get the y by itself, which is what?
How did we subtract this thing? Like, why do we do that?
Because we're subtracting the whole equation is what we're doing. Yeah, so whatever we do, like to the first x's, right, since we subtracted these, that means we have to subtract all of them. You're okay. That's fine. That was a good question. Okay, we'll divide both sides by 5, and you get y equals 2. Perfect. Now, last step is to take that and plug it in. Doesn't matter which one you plug it into, first equation or the second one. Which one do you want to plug it into? The bottom one's probably easier, right? There's less numbers. So this equation was x minus y equals 3. So I'm going to plug my y value in here. I get x minus 2 equals 3. What do I have to do at x by itself? Plus the 2 on both sides. What do you get for your x value? Good. And there you go. You have eliminated now. Do you like this one more than substitution so far?
Yes.
A little easier, right? When you go to write your final answer, which one goes first? Yep, good. 5, 2. Okay, let's do. Dun, dun, dun. I'm going to skip 3 and 4. I want to do a harder one with you. Flip to the back. Let's see, which one looks hard? Ooh, let's do 6. We'll do 6 and we can do 10. All right, number 6. Step 1. Are they lined up correctly? Heck yeah. Okay, step 2. I got to figure out which ones I want to get rid of, which ones I want to eliminate. Hello? Yes?
Is Jaden in class, please?
Which Jaden?
Jaden Murchison?
Yes.
It's Miss Owen, school counselor. Could you just have him come to my office when he has a moment?
Sure.
Thank you.
Thank you.
All right.
Here she is. In the main office.
Oh,
If you just go to the main office, they can kind of direct you from there because I don't know what her room is. Okay. All right, back to number 6. So we've got all of our stuff lined up. Which one do I want to get rid of, the x's or the y's? Which one?
The X,
get rid of the one.
Y.
Well, I want to get rid of the y's. W-H-Y. Right, these have the same number in front of the y, so always go for the one that has the same numbers. That one will tell you which one to get rid of. Now, here's the issue. I've got -3 and +3y. What do I have to do? Add or subtract those two together to get rid of them? Yeah, I have to add them, right? -3y plus a +3y. So this time we are adding our equations together, so be careful. Okay. 10x plus -2x. What? It's 8, yeah. So this is plus a negative. So you're really taking away 10 minus 2. So this might be a time where using that calculator is a really good choice, right? This is 8x. Okay, -3y plus 3y cancels out, equals 18 plus 6 gives you 24. Good. So look, something should always cancel out. That's the whole purpose of elimination. If you're left with both x's and y's in your equation, then you're not doing it right. The whole purpose of this is to get rid of things. Okay, from here it's easy peasy, right? Divide by 8, you get x equals what? 3. That's okay. And then take that and plug it in. Okay, you plug it into one of the equations, we'll see if we get the same thing. Does not matter which one you plug it into, but plug it in, we'll see if we get the same number. Anyone need another second? You ready?
Yeah.
Okay, I'll give you another second.
How are you gonna do this anyways?
What do you mean?
Because there's an X and a Y.
Right, but you're plugging this in for your x. You're taking that answer that you have and you're substituting it back into one of the equations. Does not matter which one. Okay, how many of you substituted it back into the first equation? Raise your hand. How many of you substituted it into the second equation? Okay, so yours is going to look different than mine because I substituted into my first equation. But if you plugged it into the second equation, you still should have gotten y equals 4. Did you? Perfect. Okay, and when you write your final answer? 3, 4. Good, 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 good. So make sure you're always putting that x value first. Okay, we'll do one more together and we'll do a tricky one. And then I'm going to give you some time to finish up the other ones that are left, okay? So let's do number 10. Like Miko said, number 10. Questions on that one before I slide down? We feeling okay? Do you still like this one more than substitution? Yeah, a little better? Okay. Let's slide down to number 10. Okay. Step 1. Make sure it's in the, make sure everything is lined up. Is everything lined up in this problem? No. Front row. That means I have to rewrite one of the equations. Now you got some choices. You got choices. You could, if you wanted to, since this one has the y's by itself, you could take this x and you could move it over to the other side. That's a choice. Huh? Well, how would, if this wasn't here, right, if it just looked like this, how would you get the x to the other side? What would you have to do? Well, what kind of x is it right now? It's a positive 5, so how would you get it to the other side? You would subtract it. So that's one option. I can take this x and I can push it to the other side. Another choice is I could take this x and push it to the left so that it's in front of my y. So there's multiple ways to do this problem. I am going to rewrite the top equation just because they're smaller numbers, and so they're going to be a little easier to work with. So I'm going to rewrite this top equation first. So what I want to do is get this 2x to the other side so that it matches up with this x over here where the x is first. So if I wanted to move that 2x to the other side, how would I move it over to the other side? By subtracting it. Yeah, I'm going to take that 2x and subtract it from both sides. Now over there it cancels, and you can't put an x and a y together, so it just literally writes as 4y minus 2x. But I'm going to put my x value first because I want it to match up with this one. So I'm going to put minus 2x plus 4y equals negative 8. So what I'm going to do is this. I'm now going to cross off this equation so I don't get myself confused. And I'm going to rewrite this equation directly underneath this equation right here. So this is minus 2x plus 4y equals negative 8. And now I look and I say, okay, are they lined up now? Are my x's and my y's lined up now? So now I can go through with the elimination. The other reason I did that as well was because I saw that the y's already matched up. So I was just trying to get all the y's in the same line, right? Because they have the same number in front of them. So I was trying to get my y's together. Okay, so now it's time to do our elimination. Am I getting rid of the x's or the y's? Y's. So do I have to add these two together or subtract them? You have to add them together. So let's add. What is a positive 5x plus a negative 2x? Is what? Positive 3x. What's a negative 4y plus a positive 4y? Yep, crosses off. And then what is 20 plus negative 8? Which just means 20 minus 8. 12. And now you can solve.
74.
What?
I said 74.
74?
I said 4.
Oh, Jesus. I thought you said 74. I was like, what? That's way off. Yes, x equals 4. Now you take that number and you plug it in. So here's the beauty. You have a lot of choices. You could plug it into this equation, the original one. You can plug it into this equation. You can plug it into this equation. I don't care where you plug it in. You just got to plug it in somewhere. And it doesn't matter where you plug it in.
The second one, I got,
Which one? You plugged it into this one, 5x?
yeah. but
Minus
I got
4y? Okay, hold
20
on, wait.
minus 20, 0.
Right, so hold
I
on,
have to
wait.
give it 0?
Yeah, so if you plug it into that second equation, your x value is 4, so it's 5 times 4. So you get 20 minus 4y equals 20. And yeah, you subtract 20 on both sides. So you get 0. And then when you divide 0 divided by negative 4, what do you get?
0.
You still get 0. So your y value is 0. Yeah, there's nothing wrong with zeros. You're allowed to have zeros. Okay. There's the final answer. 4, 0. 4, 0. Okay, do I have questions so far? Do we still like this one more? Still into this one more? I'm cool with that. I'm cool with that. All right, I lied. I'm going to do one more with you because,
Can we do 11?
yeah, that's what I was going to do with you. Okay. Questions on that one? Are you ready to rumble? So let's look at number 11. Now, first of all, are they lined up correctly?
Yes.
Yes, they are. Okay. Which one do you want to get rid of, the x's or the y's?
Wait, that's not a problem. I don't know which one to get rid of first.
So you want to eliminate whichever one has matching coefficients.
Both of them do.
Okay, both of them match, which means you could get rid of either one. Doesn't matter. Which one do you want to get rid of?
The X.
Okay, cool. So here's 3x, positive 3x, and a positive 3x. How would you get rid of that? By adding or subtracting?
Subtracting.
Subtracting. Okay, so let's subtract. And let's work from left to right. 3x minus 3x cancels out. What is negative 4y minus a negative 4y? What happens with minus and negative?
Cross each other out.
Yeah, they cross out as well. Minus and negative becomes a positive. So this is negative 4y plus 4y. That also cancels out. What number are you left with on the left?
2.
Whoa.
Well, negative 10.
Well, okay, sorry, the left side, this side over here. With the x's and the y's. What's left over there? Nothing. It's a 0. And then what is negative 10 minus negative 13? That really means negative 10 plus 13. Nope. Nope.
Will you add?
It's minus a negative,
I got 3.
So is it 13?
positive 3. Negative 10, it's really saying, it says negative 10 minus negative 13 is really negative 10 plus 13, which is 3. Okay, you're left with 0 equals 3. Is that true? No, this is a false statement. What does that mean for your answer?
Parallel lines in this solution.
There you go. No solution, parallel lines. You're getting it. You got it. So if you're left with nothing equals a number and it's not a true statement, then they're parallel lines. That means they are never going to intersect one another. All right, I lied. We're going to do 12 too. And then I'll let you have a little bit of time to do the last ones. Okay, number 12. You've got 2x plus y equals negative 10 and negative 2x minus y equals 10. First of all, are they lined up?
Mhm.
Yes, they are. Which one should you get rid of? It does not matter because they both have the same variables in the front. So which one do you want to get rid of? The x's, sorry, or the y's? Okay, so you've got a positive y and a negative y. Are you going to add them together or subtract them to get rid of them? Well, if you subtract them, that becomes y minus negative y, and minus a negative becomes positive. So it would really be y plus y. Does that make sense? Two negatives next to each other. So I want to make this a positive. I want to add them, right? Because positive 2x plus negative 2x, what's going to happen there? They cross each other out. What's going to happen with my y's? They cross each other out. What number are you left with on the left? 0. And then on the right, you've got negative 10 plus 10. What is that? It's 0 as well. So this time you have a number is equal to a number. Is this a true statement? Yes. What does that mean your solution is? Yes, it's infinite solutions. Because this is the same line. It's the same line. So there's no cap on your solutions because it's literally the same line right on top of the other one. So it's infinite solutions. Whew. Okay. Now let's take a break for a sec. Let's do a quick survey here. How many of you still like the graphing? Raise your hand. How many of you would prefer if I gave you an equation to do the graph? Raise your hand. How many of you would prefer to do the substitution method? Plug something else in. How many of you would prefer to do this one, elimination? Like half and half here. How many of you are open to doing all three? Okay. Just curious to see what we like and what we don't like in here. It's interesting that we like elimination the most, it seems. Which is funny because the first time around we taught substitution, you guys were all like, I'm going to graph forever. I hate this one. And now look at you. Now none of you want to graph. How the tables have turned. Okay. We've got like 6 more minutes. I would like you to try number 3 and 4 on the front. Okay. So take the last few minutes here. I want you to try 3 and 4. Sorry, I'm sorry, I keep looking on you. I want you to try 3 and 4 on the front side. Okay. And then when you're done with those 2, we'll be done for the day. Okay. But try those 2. And then we'll come together. We'll see how you did.
I just forgot.
Forgot what?
I just figure out here one thing I did.
So remember, first step is make sure they're lined up. Okay. Second step is find the ones that have the same coefficient. Okay. So then you have to tell yourself, do you want to add together the 3's or subtract the 3's to get rid of them? What do you think? Why? Okay, so then you're going to subtract the whole second equation.